Hello everyone. Today our topic is nature and composition of the atmosphere. We will learn from the topic definition of the atmosphere, nature of the atmosphere and composition of the atmosphere. So now let's see what is the definition of the atmosphere. The atmosphere is a blanket of gases and suspended particles that entirely envelop the earth, which is extended outward several thousand of kilometers. And this gaseous cover of the earth is attached with the earth itself by gravitational attraction, and the atmosphere it also rotates with the earth like lithosphere and hydrosphere. The atmosphere is also an integral part of this planet. We know that air is colorless, tasteless, odorless substance, and it is highly compressible and it flows from one place to another place horizontally. This horizontal movement of air is known as wind. Above each location on the earth, there is a column of air that stretches up to the top of the atmosphere. The pressure that air molecules of the column of air exert on the surface is called atmospheric pressure. Density and pressure of the atmosphere that decrease rapidly with altitude. About 50% of the total air mass is found below 5 km, and 99% of the total air is concentrated within 30 km from the Earth's surface. So the maximum atmospheric pressure is found at the mean sea level, which is about 1013.25 millibar. And with altitude, we see the density of air become lesser. As a result, the pressure also become lesser. We know that atmosphere is a significant part of the Earth's surface. Now let's see the significance of the atmosphere. First, we know that atmosphere helps to maintain the sustainable temperature of the Earth's surface for human or other organisms living. If there is no atmosphere, there would have been great extreme of temperature between day and night. In this situation, life would be impossible on the Earth. Second thing, that the atmosphere protects us from the ultraviolet ray. We know that ultraviolet ray is very much harmful for living organism. There are three types of ultraviolet ray. There we see ultraviolet ray A, B and C. If we see the wavelength of that ultraviolet ray, then UV ray wavelength is greater than UV ray B, and UV ray B wavelength is greater than UV ray C. So shortest wavelength is found in UV ray C, which is also most dangerous among them. And this UV ray C is totally absorbed by the ozone layer of our atmosphere. UV ray B maximum part is absorbed by the ozone layer and some part that reaches at the Earth's surface, and UV ray A that reaches at the Earth's surface. It cannot be absorbed by the ozone layer. So from this harmful effect of ultraviolet ray, our atmosphere protects us. Also, we see that our atmosphere shields us from the bombardment of meteors. Another significance of our atmosphere is that it helps to maintain the latitudinal heat balance of the Earth. We know that highest temperature is found in the tropics and subtropical region, which receive maximum amount of insolation over the year. On the other hand, we see that lowest average temperature are recorded in the polar region or subpolar region in both hemispheres. So where amount of solar energy received in the course of year is very small. In spite of these imbalances, neither the tropical region get progressively warmer nor the polar region get progressively colder. We see intense heating in low latitude would cause the air to expand vertically and move poleward at the higher atmosphere, where it would sink to the ground level and it would give up its heat. An intense cooling process in the polar region would cause the air to flow towards the warmer equatorial region. So, in that way, a surface level flow of wind from high pressure polar region to low pressure equatorial region take place, and the upper air circulation take place from equatorial region to the polar region. So in the way the heat latitudinal heat balance is maintained. Because of the ionized particles present in the thermosphere, it is also called as ionosphere. This ionosphere helps to reflect the radio waves, and for that reason we can broadcast and telecast different program. We can watch rather this program in our television. Along with that, we know that our atmosphere is composed of different gases element. Among them, oxygen is a key element of living organism. Nitrogen, that is the main source of protein element. Water vapor, that is because of the presence of water vapor, we know that precipitation takes place on the earth's surface. So we can say that suitable atmosphere is the main reason for the development of life on the earth's surface. Composition of atmosphere are influenced by several factors. Factors like elevation, latitude and season, time, they impact or they influence on the composition of the atmosphere. Now let's see the impact of elevation in the composition of atmosphere. The element which get influenced by the elevation, first one is water vapor, second is ozone, third one is aerosol. Aerosol. Now water vapor, it comprises up to 4% of the atmosphere by volume near the Earth's surface, but it is almost absent above 10 to 12 kilometers from the Earth's surface. On the other hand, if we see the concentration of ozone, that is maximum at the elevation of 22 to 35 kilometer altitude from the Earth's surface. Very insignificant level of ozone present in the troposphere. Its maximum concentration found in the layer of stratosphere. Presence of aerosol also decreases with elevation. Maximum concentration of aerosol is found near the Earth's surface. With elevation, aerosol's presence also decreases. And main sources of aerosol is different anthropogenic activities. And present time, the amount of aerosol is increasing due to anthropogenic activities. Now let's say the variation in atmospheric composition with latitude and season. In this regard, water vapor and stratospheric ozone are particularly important. If we see, ozone content is lower over the equatorial region and it is higher in the subpolar region in springtime. Again, if we see water vapor content of the atmosphere, it is related to the air temperature and in low latitude, it is greatest in summertime. And if we see variation of atmospheric composition with time, then we'll find that the composition of atmosphere that we see today is not same as at the beginning of the earth. Its composition has been changes gradually over time. We know that presence of greenhouse gases, specifically carbon dioxide, has significantly increased after industrial revolution. In the same way, due to different anthropogenic activities, presence of dust particle or aerosol has also increased in our atmosphere. Okay, next move to the different gaseous element in our atmosphere. First one, we can say that nitrogen and oxygen. These two gases comprises almost more than 98% of clean and dry air. And these primary gases, their mixes remarkably constant proportion up to 100-kilometer altitude. This table is showing the average composition of dry atmosphere below 25 kilometer. Next, carbon dioxide, ozone, methane. These three gases present in the table, they are known as greenhouse gases. In spite of their scarcity, the so-called greenhouse gases play a crucial role in the atmosphere. Apart from these three greenhouse gases, there are other greenhouse gases like nitrogen oxide, N2O, chlorofluorocarbon, CFCs, which is commonly known as, and hydrogenated halocarbons, that is commonly known as HFCs. So these are also greenhouse gases which present in the atmosphere. Another important greenhouse gas is water vapor, H2O. Now we know that greenhouse gases trap radiation emitted by the earth and thereby produce the greenhouse effect. Because of this greenhouse effect, the earth is suitable for living. The concentration of these greenhouse gases are strongly affected by the anthropogenic activities. Now let's see the major sources of these greenhouse gases. First important greenhouse gas, you know, that carbon dioxide. Major source of carbon dioxide is Earth's interior, fuel combustion, respiration, etc. As well as another thing, that oceanic evaporation. At the time of oceanic evaporation, a significant level of carbon dioxide also included into the atmosphere. This carbon dioxide dissolves in the ocean and also it is consumed by the plants at the time of photosynthesis. But the imbalance between emission and uptake by the ocean and terrestrial biosphere leads to the net increase of the carbon dioxide in the atmosphere. Next significant greenhouse gas is methane. Methane is basically produced through through anaerobic process. Anaerobic process means in oxygen deficit environment by natural wetland, then paddy field, etc. Together, this natural wetland and paddy field, they produce almost 40% of total methane production. Almost two-thirds of total methane of atmosphere, they are generated due to anthropogenic activities. Next significant greenhouse gas is nitrous oxide. Nitrous oxide major source is nitrogen fertilizer. Along with that, industrial process, then transportation, then some biological mechanism. These are the major sources of nitrous oxide. Another greenhouse gas is ozone. In fact, tropospheric ozone. Ozone is produced through the breakup of oxygen molecules in the presence of ultraviolet ray in the upper atmosphere. We know the maximum concentration of ozone is found in the stratosphere, and it is destroyed by the reaction involving chlorine in the upper stratosphere. In case of tropospheric ozone, in the presence of sunlight, nitrogen oxide and volatile organic compounds react and they produce ozone. Now, what is this volatile organic compound? Now, this volatile organic compound are those compounds which contain carbon and they can quickly turn into vapor or gases. Volatile organic compound basically released from burning of gasoline, coal, glues, dry cleaning product, etc. It is a major reactive gas species which is released due to anthropogenic activities. Chlorofluorocarbon or CFCs. In fact, CFC along with HFCs, that is hydrogenated halocarbons. These two are also significant greenhouse gases. These two greenhouse gases, CFC and HFC, they are entirely anthropogenic gases. CFCs are produced by aerosol propellant, refrigerator, air conditioner. Until 1930s, there were no presence of CFC in the atmosphere. Due to anthropogenic activities, the presence of CFC has gradually increased in the atmosphere. An average lifetime of CFC in atmosphere is 65 to 130 years. Comparatively, HFC's average lifespan is less than chlorofluorocarbon. It is about 7 years. So for that shorter lifespan, HFC is used as a substitute of chlorofluorocarbon. But still, these HFCs have substantial greenhouse effect. Another greenhouse gas is water vapor. And we can say that water vapor is a primary greenhouse gas. Next, move to reactive gas species. Key reactive gases are tropospheric ozone, carbon monoxide, volatile organic compound, that is VOC, reactive nitrogen gases, and reactive sulfur gases. These reactive gases play important role in the Earth atmosphere. They impact the climate system. Some species are direct greenhouse gases, while others have a strong effect on the oxidation process. Along with that, in urban environment, emission of these reactive gas species are precursor to photochemical smoke and haze. Both have an adverse effect on the human health as well as on the plant. Now let's see some species. First one is nitrogen gas species. The reactive species of nitrogen are nitric oxide and nitrogen oxides. Fossil fuel combustion is their primary source, as well as biomass burning and lightning activities are also important source of this nitrogen species. Reactive species of sulfur are sulfur dioxide and reduced sulfur. Reduced sulfur means H2S or DMS. DMS, that is dimethyl sulfide. More than 90% of that sulfur species come from coal and oil combustion as well as copper smelting. And another important reactive gas species is VOC or volatile organic compound. Significance of this volatile organic compound in atmosphere is associated with their oxidation product, which promote formation of ozone, carbon monoxide, and aerosol. And it can be oxidized to organic acid, which contribute to atmospheric acidity. In fact, these nitrogen species and sulfur species, they play important role in acid precipitation. Next, aerosol. Aerosol is colloidal stuff that's suspended in the gas. In case of atmosphere, there are significant quantities of aerosol present. This suspended particle of sea salt, mineral dust, organic matter, smoke, etc. are included. We can classify the origin of aerosol into two groups. One is natural sources, another one is anthropogenic sources. Natural sources are desert, dust, or we can say soil dust, then sea salt, volcanic dust, organic particle, ocean sulfate, etc. And anthropogenic sources of aerosol are like industrial sulfate or black carbon, which is known as soot, etc. Basically, burning of fossil fuel is the main sources in this category. So that's all about nature and composition of atmosphere. I would suggest to go through these books. There are three books, and you can also visit Google for better understanding. Like you will get some good diagram as well as animated diagram that will also help to understand the topic. Okay, thank you.